Good day, students. How are you doing? So today we go straight to circle theorems, and last class I've spoken about arc, segment, sector, circumference, and all that. So today we're going to start with the first theorem, and then the first theorem states that the line which joins the center of a circle to the midpoint of a chord is perpendicular to the chord. Okay, the line, now look at this circle, the line that joins the center of the circle to the midpoint of the chord is perpendicular to the chord. All right, so I hear what I'm trying to say. So that means this is the midpoint of the chord, and this line joins it from the center of the circle. So, in questions like this, we apply Pythagoras theorem and the our popular SOHCAHTOA. You remember SOHCAHTOA? Sine equals to opposite over hypotenuse, cos equals to adjacent over hypotenuse, tan equals to opposite over adjacent. That's what we apply. All right, so let's start with the first example for the day. A chord AB of a circle is 45 centimeters long and its radius is 41 centimeters. Calculate the angle subtended at the center of the circle. Are you there? Calculate the angle subtended at the center of the circle. So the first thing we are going to do is to draw it, or sketch it. We have something like a circle like this. Look at it. Sketch this circle. It's a sketch. Don't mind my circle. All right. I know some of you are laughing already. We have something like this. Okay. Now, we're told that the chord is 45 centimeters long. So this from here to here is 45 centimeters. All right. And the radius is 41. So this is radius 41 centimeters. All right. Calculate the angle subtended at the center. We're looking for the angle here. But you see, we can get a bisector from the theorem. That this is 45, from here to here is 45, and this line divides into 2, so this place will be 22.5. That's 45 divided by 2, 22.5. Do you get that? So this is 41. Do you get that? And so we are looking for the angle at the center, but if we can get this angle, we just multiply it by 2. Do you get that? I remember that this is perpendicular from the theorem. All right, from the theorem up there, this is going to be 90 degrees. So let's try to get this angle here. Let's call it angle theta. Whatever we get here, we're going to just multiply it by 2. Because two things are bisected, this angle and this line. Are you getting me? All right, so we have something like this. (41 centimeters). We have 22.5 centimeters. All right, and we have theta here. Okay, so we're looking for this angle. Using SOHCAHTOA, this is opposite. All right, this is hypotenuse. All right, so we have sine theta equals to 22.5 over 41, right? So if you use your calculator, sine theta equals to 0.5488. all right, so we have theta equals to sine inverse of 0.5488. So theta equals to 33.28 degrees. So that's the theta. That's the angle that we're looking for. That's not the angle we're looking for. All right. So how do we now, we can approximate this to 33.3 degrees. So we now say angle subtended at the center will be equals to 2 times, all right, 2 times 33.3 degrees. And that's what? 66.6 degrees. Is that clear? Is that clear? All right, so let's look at another example under the theorem 1. Okay, another example. All right, so let's look at this example. The radius of a circle is 14 centimeters and the chord has a length of 18 centimeters. Find its distance between the chord and the center of the circle. Find its distance between the chord and the center of the circle. So the first thing is we sketch it. If you don't sketch it, solution, you may not get it properly. You sketch. All right, we're told that a chord has a length of 18 centimeters. Let's draw a chord like this. It has a length of 18 centimeters, and we have a radius of what? 14 centimeters. So this is 14 centimeters. You can also draw it like this, 14 centimeters. We are now looking for the distance between the chord, all right, and the center of the circle. We're looking for the distance. Remember that this line will bisect this. So this is 9, this is 9. Are you get what I'm trying to say? You are looking for the distance x. Let the distance between, all right, let's call the center O, let's call this A, all right, between the center O and the chord AB be x. Are you get what I'm trying to say? Be x. All right, so this is x, this distance. Now you see that this is 9 centimeters, this is a right angle triangle. So we can use Pythagoras theorem. Let's bring out one of the triangles. They are equal triangles. This is 9 centimeters, 14 centimeters, and this is x. So using Pythagoras theorem, we have x squared. All right, x squared plus what? 9 squared equals to what? 14 squared. So x squared plus 81 equals to 196. X squared equals to 196 minus 81. X squared equals to 115, right? X equals to 115, square root of 115, right? Are you with me? So we have x equals to 10.72 centimeter. So that is the distance between, all right, the chord and the center of the circle. Is that clear? Is that clear? All right, so let's take one more example for the day. Let's take one more example for the day. All right, I'm going to write that. We have, pay attention to this. Let's use this. Pay attention to this. A chord 15 centimeters long is 8 centimeters from the center of a circle. Okay, find the radius of the circle. Okay, so that's simple. A chord 50 centimeters long is 8 centimeters from the center of a circle. Find the radius of the circle. So let's have something like this. Let's sketch it. Okay, we have something like this. Okay, something like this. Okay, now we have a chord 15 centimeters. We have the center arbitrary. Okay, and it's 8 centimeters. This is 8 centimeters, and then we're looking for the radius x, or let's call it y. You get that? Now remember that this 15 centimeter now, this line will divide it into 2. Okay, so this will be 7.5, this will be 7.5. Did you get that? It will be 7.5, 7.5. So we have something like this. Let's draw the triangle properly now. We have something like this. Okay, 7.5 centimeters, 8 centimeters, and then we're looking y. That's the radius we're looking for. Okay, so using Pythagoras theorem, we have y squared equals to 8 squared plus 7.5 squared. All right, so we have, y squared equals to 8 squared plus 15 over 2 squared. Okay, y squared equals to 64. We have, by the time we're done, we have y squared equals to square root of 481 over 4. Okay, so we have y squared equals to square root of 120.25. Okay, so y equals to, sorry, y squared, this is y equals, there's no, when you put y equals to square root, there's no more square there. Pay attention to that. That was a mistake. So y equals to 10.96 centimeters. So that is the radius of the circle. Is that clear? That's the radius of the circle. So we stop here for today, and later I'm going to send you some classwork for you to study. Thank you and have a great day.